Ever thought of contributing to solving clinical diseases with biomaterials research? For example, to create 3D scaffolds or injectable materials that can support bone defect treatment, microneedle patches that can transdermally deliver therapeutics, while elastic micropatterned patches that can repair wounded heart tissues. How can we make these fabulous structures? The answer is photocrosslinkable polymer. At PolyU, our lab is devoted to the development of photocrosslinkable polymers. Photocrosslinkable polymers are polymers that can be solidified from liquid upon light exposure. As light provides the energy for chemical reactions, the liquid monomers join together and form a cross-linked solid polymer network. The more polymer chains join together, the higher density the network has, and the stronger the material. Photocrosslinkable polymers developed by our lab can be used to promote the regeneration of diseased or damaged tissues. The polymers can be fabricated into various formats. For example, they can be injected into cracks and fill into defects of various dimensions for regenerating tissues such as bone and cartilage. With the help of computer-aided design, we can 3D print the materials according to the patient's need and create personalized 3D scaffolds for bone regeneration. They can also be fabricated as a microneedle patch to deliver drugs for scarlet wound healing or to restore the cardiac functions. Photocrosslinkable polymer is like a transformer. They can be fabricated with different structures and with different mechanical properties. We aim to use these photocrosslinkable polymer transformers to solve various clinical problems. At PolyU, our knowledge not only leads to new findings, it also advances scientific development and paves the way to a future that benefits mankind.